represent functions as rules and tables. So what we're going to talk about for a while here is this idea of how you relate data together and when one affects the other, and that's kind of what happens when you have what's called a function. And a function consists of two things. They're called domains and ranges. The domains are what are called inputs also, and the range is called the outputs. That's the set of numbers that are called the outputs. The domain is the set of numbers that are the inputs. So the easiest way of seeing this is probably an example. For example, here, if you were to buy 10 gallons of gas, and this was apparently a while ago, it would cost you $19.99. If you were to buy 12 gallons of gas, it would cost you $23.99. 13 gallons of gas, $25.99, and 17 gallons of gas, $33.98. And yes, if you look here, it says that gas is $1.99, which would be pretty cool, but it's not now. So when you're asked what the actual domain, the domain and the range, are actually asked to identify the domain and the range, all you need to do is you just need to list all these numbers. And so the domain is just going to be these: 10, 12, 13, and 17. And the range is just going to be these: $19.99, $23.99, $25.99, and $33.98. So that's just how to identify those things. In terms of practice here, so the input is going to be the domain, so it's just going to be 0, 1, 2, and 4 for the domain, and the range is going to be 5, 2, 2, and 1. Now, one thing that can happen, and that's what happens in this is why it's drawn out this way for this data set, is that you can have an input that leads to the same output. In this case here, 1 to 0, 2 to 1, and then 3 and 4 both go to 2. That works as a function. However, you can't do it the other way around. You can't have something like this where the input is going to be, if the input was going to be 0 and then 0 again, and then 1 and then 2, you can't have this be 5, 3, 2, and then 1, because then when you put numbers into the function, the value of the input would, the value of the output would change, and that just doesn't work, because then you wouldn't know what output to choose. So that's important to know, because in this example here, what we have is we have 0 leading to both 2 and 3, and then 5 leading to 4, and then 10 leading to 5. This here is not a function, because you wouldn't know what the output was, because the input has two different values for the output. This one here, 0 to 0, 1 to 2, 4 to 8, and 6 to 12. There, the pairing is fine, because the input, each input value leads to only one output value. That is what defines that definition of a function, gives that definition of a function. So here, tell whether each pairing is a function. All we got to do is we just got to look at the top here, the input 3, 6, 9, 12. Well, it's a function, because 1, 2, 2, 1, it doesn't matter what the output is. Here, 2, 2, 4, 7, now we got to look at the output for the 2 and the 2. The output is different, so therefore, for each of the 2's, so therefore it is not a function. Now, in terms of function rules, there's two different things here. There's what's called the independent variable and the dependent variable. And most often what you'll see this in an equation that has a form where it has y and x. In this case here, the x is what's going to be called the independent variable. This is the independent. And this is going to be, the y is going to be the dependent one. Because the reason why that works that way is that that's just what's been agreed upon over centuries. That x is what you're going to be plugging numbers in most of the time, and y is what the actual answer is going to be when you plug in a value for x. This value of y this value of y is going to depend on what the value of x is. Let's look at a couple of examples of this. So this is an important key concept, as it says. If the verbal rule is the output is 3 more than the input, that means that if we call the input x and the output y, then x plus 3 is equal to y is going to be the actual equation, and most of the time we'd write it this way. So y is equal to x plus 3. So very clearly here, that's how it's written down there. Just want to remind you, you can switch things around in terms of the order of things if you feel more comfortable. But we should, the consistent way of doing it is most of the time this way, but this is just a refresher that it doesn't matter which side something is on in terms of an equal sign, as long as it's equal. So this is what the chart's going to look like. If the input is 0, then the output's going to be 3, because 0 plus 3 is equal to 3. If the input is 1, then it's going to be 1 plus 3 is equal to 4. If the input is 2, 2 plus 3 equals 5. If the input is 3, 3 plus 3 is equal to 6, and so on. And if you have 4 plus 3, it's going to be equal to 7. Sorry for my writing there. So that's the key to understanding this whole idea of functions. And here it says make a table for a function. The domain of the function is of the function y is equal to 2x. So the domain, this is going to be our equation. The domain, so that's going to be, that's the independent variable. So we're going to plug in 0, 2, 5, 7, and 9. And each time, this is what this is showing here. And if you plug in x for 0, that's what this one here is. 2 times 0 is 0 minus 0. Is 2 times 0 is just equal to 0. 2 times 2 is going to be equal to 4. 2 times 5 is equal to 10. 2 times 7 is equal to 14. And 2 times 8 is equal to 16. So the range is going to be the numbers on the bottom, 0, 4, 10, 14, and 16. Moving on here. In terms of writing functions, what you have to figure out is you have to figure out generally it's one of two possibilities. It's either going to be a number that's multiplied by x, so something in front of the x, or it's going to be something that's added to the x. And we're going to get to, sometimes you can even combine both, and then it gets more fun to work those out. So if you look here, write the rule for the function. We're relating the input to the output. Well, the input starts at 0, goes up to 2, then the next one 1 to 3, 4 to 6, and then 6 to 8, and 10 to 12. So what we're doing is we're relating this x to that y. And probably you can see that it's just going to be y, we started off with y is equal to x plus 2. That is just going to be our rule for that function. Now moving on here, write a function rule for a real-life world situation. You are buying concert tickets that cost $15 each. At a cost of $15 each, you buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. So you're trying to figure out a way of relating the actual amount of tickets you buy to the actual amount you're going to spend. So it's written out very nicely here in a verbal model. The amount spent, the total amount, is going to be the cost per ticket, which we know is going to be $15, times the tickets purchased. In this case here, they change N, they use N and then A, the amount spent. So this thing here, this is the independent variable, this is the dependent variable. And now if you want to go ahead and fill out that chart, you can. For 0 tickets, it's going to be $0. For 1 ticket, it's going to be $15. For 2 tickets, $30. For 3 tickets, $45. 4 tickets, $60. 5 tickets, $75. And 6 tickets, $90. That's how it works in terms of that. In terms of, let's look at this example, a couple of these examples here. Make a table for the function y is equal to x minus 5 with the domain 10, 12, 15, 18, and 29. Interesting set of data. So it's y is equal to x minus 5. So what we're just going to do is we're just going to plug this in. We'll draw out this table here. So this is going to be the x, this is going to be the y, and x minus 5, we're going to write up what the x is. It's going to be 10, 12, 15, 18, and 29. Okay, so now we're just going to do 10 minus 5, because that's what, if we plug in 10 for the value of x, that's just going to be 5. Should look more like a 10. That's 12 minus 5. It's going to be 7. And you can figure this out. 10, 18 minus 5 is going to be 13. 29 minus 5 is going to be 24. It's a good idea to sort of write these things out, especially as they get more complex. This one here, probably you can do in your head. But if you can't, then you certainly can write these out and do it all the way down. So 18 minus 5 is equal to 13. But as they get more complex, you might. So now we're going to try and write a rule for this function here. It says here the time versus pay. Apparently, how much you're being paid per hour. So how you look and you see if there's a pattern that you can figure out. So each time the time goes up by 1 hour, the value. So each time the time goes up by 1 hour, the value is going up by 8. That's one way. Oh, let me fix that. Value is going up by 8. Okay, and you probably guessed that 5 is going to be 40 and 6 is going to be 48. Is what's happening. So how do we relate these two things together? Well, what you do is you try and figure out, well, it's going up by 8 each time, so it's going to be the time, that's t, times 9 is going to be equal to the pay. And if you wanted to find those by writing that out, that's fine. Or you could write it out like this, pay is equal to 9t. That works as well.